Thank you. So I'm the last to give a talk today. So hopefully you guys can get to San Juan, right? So hopefully you guys enjoy this one. This is another tool and another collaboration with HP Lab and our team here. I think in the afternoon, what you guys have seen mostly, it's this research about this interaction between the IT and facilities, how we can merge those into, make more efficient, energy efficient data center. The idea then at the end is learning how that interaction occurs. So then we can, as Martina mentioned at the end, using then other energy sources to finally say, you are at a net zero in terms of energy consumption. But first, you need to understand that interaction between your IT equipment and the resources, your cooling resources. So this research that has been going on and in HP Lab for some years have developed some very cool and interesting tools. As you saw, Carlos mentioned dynamic smart cooling, the use of CFD tools, as Felipe showed, and different new products that we are working on, like containerized data centers, what you guys saw that Jose presented you. So this is another tool that has been developed. It's focused more on when we were doing analysis, thermal analysis for data centers, using CFD tools, as Felipe mentioned. And we wanted to add more, let's say, intelligence, more value to the information you can get from doing a thermal analysis to your data center. And what we have done is use some of the research and that has been developed to create these tools that they presented into our services of thermal assessments. So we call this tool thermal zone mapping. So basically, I will give you guys a brief description of what it is, and then I'm going just to show you some images, and hopefully you guys understand, and then later you can ask me some questions about it. But basically, it's a tool that we use with CFD analysis. And when you saw some images from Felipe's presentation, you saw these thermal maps, right? So you see these servers in your data center room, and you see like red zones, or because the scale is that red is hot air, and like blue is it's cold air, right? So you see these thermal maps, and that gives you a sense of where your cooling resources are being developed, and how you're managing your exhaust air, your hot air, back into your cooling units, right? What this tool gives you, it's another way of looking at the interaction between your servers and your cooling units. And what it basically do is you are able to visualize in 3D the region of influence that a particularly air handling unit or crack unit have on your data center, how far it reaches, and by not only how far and visually, but what is the level of percentage. It's 50%, 20%, how much I can change the conditions in a particular location or for a particular server by that air handling unit. So that's basically what thermal zone mapping is doing right now. We use it internally and also for customers. It has been a great tool to help us understand where a placement of new equipment in the data center we can put there. We can model failure scenarios and see how our cooling resources interact and are managed. And basically it's to not only for data centers that are already running, but for future designs. If your cooling solutions are properly managed, or what things you need to do to have better control of your data center. So, as what all of the guys before me they said, it has been a collaboration with HP Labs. HP was one of the first companies that used CFD as a tool to optimize the thermal performance of data centers like 10, 15 years ago. And their research about trying to understand how it's that interaction between the servers, so we can give cooling resources when are needed fast enough and efficiently, has bring up a lot of new theory, new results that we are using those technologies that they develop and calculate this matrix and this new way to visualize your efficiency in your data centers by doing first a thermal assessment, a model of your data center, where we extract your results of temperature and pressure and velocity of the air, and we calculate this new matrix and then visualize them. Okay. So this is a graphic representation of what I try to say right now. So this in your left side, you can see this is a data center. And here is more of a sketch or a drawing, a top view. So you can see here, let me see if, here are your air handling units, your crack units, air conditioning units here at the end, and this blue will be rows of server, right, as you saw, and then normally a conventional data center, you have perforated tiles, right? So when people do CFD analysis, you will generate these temperature plots, right? So you will see, well, this will be your cold aisle, so I should expect cold air, and then at the rear of the racks, we will have the exhaust of the servers, right? So it will be, you have hot air. Now, in this kind of plots, you can say, yes, you know, I have well cool my servers, but if you want to see really what is the real interaction between, let's say, this particular rack in this location to any of those crack units there, what is their relation, how any change in my crack units affects that server, that's where thermal zone mapping goes. So we use this data, we perform some formulations, and we calculate a thermal matrix that we call thermal correlation index. It has been presented in papers throughout the years by HP Labs. And what we are doing is we are visualizing that thermal correlation index. So in this case, you see these plots here, these clouds. What we're painting here with color is the region, for example, on this image here, is this crack unit here and at your top left, the region in the data center that affects 25% or more. So for any change in a degree that you give to in your settings on your air handling unit, you are affecting the temperature in that location by a quarter of the degree, by 25% or more. It could be even by the same degree. So you can now see how the region that particularly air handling unit has and affects your IT equipment. And we can do those kind of plots and visualize that for any of the air handling units in your data center. If I go back, the idea was when we thought, and the concept that HPLAT has was it would look like clouds, like round, very symmetric forms, but really how the air interacts between the different equipments and even at the race floor gives you very irregular shapes. So for each of the air handling units, we can see that how they influence your room. Now, if you superimpose all of those plots, what we then understand is that in some regions you will see darker zones, and it's because you have influence of this air handling unit, but also influence of another one. So you have redundancy of cooling resources, and in this sense, it's a little bit complicated to see that kind of analysis in this kind of plot. So we came with two ways that we think are very useful and are some features of the tool. And it's in these regions that you have redundancy of cooling resources. You may want to know exactly for that server if I need to that server is hot and I need to change his temperature condition. Which of those crack units will give me the faster response? So what we do is we analyze the data and generate what we call domain region plot. And what it gives you is that even though, for example, here we have like 2 air handling units that affect the temperature on that region, really the crack unit on the top is the one that has the strongest influence. So if you want faster response on that region, if you have problems in terms of temperature, you go first to that air handling unit, and then you can go to your second unit. So it generates like this geographic, you can generate this geographic kind of plots, right? I know we are short of time, so I just want, these are views from the tool. It's 3D. What you saw on that first one was a top view, but we have, our tool is 3D, so we can see it at any direction and create the planes in any place we want. And we added a new feature, which is seeing those regions of influence, but at the front of the rack, where you would like to see your cooling resources getting into the front face, right, of your server. So we can generate those plots that you saw, but then at the inlet of the rack units. This one, let me go back. This one is we call overlapping regions, and the things we see is that there are going to be some places in your data center based on your design that you may have areas that 2 or 3 or maybe 4 more crack units can influence that area. So you have their cooling redundancies. That is, we think, good to know in your data center, because then you can place there some mission critical or some equipment that it's very important to have redundancy of cooling resources, or that you can react faster. So knowing those areas in your data center, we think it's very good to know, and this tool can give you that. So you see, this analysis it goes far from seeing thermal plots of temperature plots or pressure plots, but showing you more analysis of this interaction between your cooling resources and your IT load. We can use this tool not for conventional data centers also, but for new kind of designs like hot aisle containment or cold aisle containment. So in this case, for example, it's a hot air containment, and we can show we have this design has duct here, so each duct will have cool air coming out, and we can even use it to analyze exactly how well the air coming from each of those supply points affects your different servers. And you can have them optimize your design better. And then just to end here is just show you a customer case, real case. We had a customer, they wanted to, their objective was to reduce their operating expenses. So they wanted to understand that interaction between their air handling units to their servers to see where they can save in terms of energy. This design, it's a cold aisle containment. So even though it has a raised floor, they seal the cold aisles, so they have perforated tiles, but the cold air goes only in front of the servers. So one of the things we did a CFD analysis. We also did an analysis of how their utilization in the data center, and then we used thermal zone mapping to understand then at each zone inside of their own cold aisle sections, each of those crack units, how much they influence there. Once we did that analysis, as you can see here, this is another picture in front of the servers. We can say, well, for that row number A, the crack unit that has influence is number 32. We have some areas where we have 4 or maybe 3 air handling units. So what we did was we combine our knowledge now of seeing, we know what is the influence of each crack unit, if it's low or medium or high. We know how much their utilization, they're not doing too much of the work. So by using that data, then we can identify those air handling units that we can turn off, because the ones that will be turned off normally will be their utilization is low, and also their influence is low. They're not doing pretty much anything very low in your data center, but you have it on, right? With that analysis, we were able to reduce, turn 3 crack units on their data center, and savings were around in the $45,000 per year. So it's just an example of using CFD tools, as Felipe showed you, but then these new tools that we have from research that has been worked with HP Lab these past years, as another example that you guys have seen this afternoon about. Okay. So hopefully I finish. And I don't know, any question? I guess the idea right now was to, before leaving, if you guys have any question, not only for me, but Carlos, also Jose or Felipe, of what you guys have seen.
Have you set any PODs in Puerto Rico?
No, that I know.
For any client?
That I know, not yet. POTS?
No.
No.
No?
In the island, no.
There was one customer at one time that were looking into that solution.
Mm-hmm.
But again, like I said, POTS is a good solution, but EcoPOTS is not, because it uses outside air. But I think that was the only instance.
Yeah, because if you have set up a POD a pod in Puerto Rico, I would like to know what you guys did for air recycling and cooling systems and stuff. Would be pretty interesting, or a very case study.
Kind of to Omar's question. What are some of the largest data centers on the island?
From HP or?
No, just
No,
in general,
around?
because I mean, part of the problem with the pod approach is you've got to have the scale.
Yeah.
And I'd kind of question as to whether the scale exists on the island to warrant it.
Well, the biggest ones here. Run. I belong to the computer, you know Ramfi Castro, right? From Colegio de Ingenieros. Well, I do some consulting for Ramfis, and he's in charge of computer engineers in Puerto Rico. And we found out that the biggest data centers in Puerto Rico belong to the private sector, and most of them are with the pharmaceutical companies. But in legacy units, the government has the biggest ones, and they are, for example, OGP in Puerto Rico, which are the people that work with where our CIO is located at, and there's some medium-sized data centers there. Nothing like maybe what you're used to see, but the biggest ones are, it's a share position. Government has EOP, which are, I think, they are the biggest ones as far as how many servers they have. And the pharmaceutical companies, I've seen the Amgens and the Juncos, and the data center there, it's considerable. The other one is, well, Intel left us like 10 years ago or 15 years ago. That was the biggest one, actually. And then one, which was bought later on by Intel. But the biggest one that I know in the island right now are those two.
Yeah, I guess in terms of, like you mentioned, the problem with the largest data center in Puerto Rico is the old equipment, legacy equipment they have. That's a problem, trying to efficiently manage those. So that's one of the problems we have found. It's trying to manage old equipment. With these technologies, we can go as far, but not that much. I mean, you have a huge amount of power consumed by the equipment itself, that the cooling that you save is just minuscule.
I know
Yeah.
Department of the Tourism in Puerto Rico on La Princesa, they used to have a very big one underground, but they moved it to Blancolaya later on. And I'm pretty sure OER, which is health systems, it's as big as a basketball court, but it's a legacy. They still have those old servers, and the place is scary because you're gonna walk through AS400s and a lot of legacy servers there that still work, and they are efficient for what they do, which is warehousing and stuff like that. But we don't have like these places where you can go and have I don't know, data centers like bigger than that.
Okay, wrap it up. Thanks, guys. Much appreciated.